So, I welcome you students for this study on isomers. This is the last session in coordination chemistry. Now, we are going to look at the structural isomers, and the structural isomers can be of four important types. One is called linkage isomerism. If you have an ambident ligand is one which can be linked through either of its atoms one at a time. Thiocyanide, NO2, CN are ambident ligands. Mind you, NO3 minus is not an ambident ligand, only NO2 is ambident ligand. Okay. Now, when you have an ambident ligand, the ligand can be linked through either of the atoms. That makes a set of different compounds. For example, Jorgensen has pointed out that this compound where pentamine nitrato O cobalt 3 chloride, when O is linked, that has red color. When this complex is such that nitrogen is linked, the NO2 nitrogen is linked, then it is called nitrato N, pentamine nitrato N cobalt 3 chloride, that has characteristic yellow color of nitrogen containing nitro compounds. Nitro compounds generally usually have yellow color. If nitric acid falls on your skin or hands, they will get yellow color, right? So, anyway, linkage isomers are such pair. They have different colors, different properties. Now, coordination isomers. Now, if you have a complex salt like thing, that is, a complex is having cationic and anionic form. Cationic form has certain ligands, anionic form has a different ligands. You can take here as example hexamine cobalt 3 hexacyanochromate. If you take that type of complex, there is a possibility that there is an exchange of the ligands. The chromium may take the ammonia, that is, chromium can come here, cobalt can go there. Such exchange, the metal ions exchange the ligands, that generates what is called as coordination isomerism. And then ionization isomerism means, it's a very strange name anyway. What happens in a certain complex, if for example pentamine sulfato cobalt 3 bromide, if you add silver nitrate, it will give a yellow precipitates of silver bromide, because the bromide is the outside the coordination sphere, it is satisfying only primary valency. However, if the Br comes in, SO4 goes out, then that makes the ionization isomer, and the ionization isomer, that is pentamine bromo cobalt 3 sulfate, if it is added with silver nitrate, it won't give any precipitate. But this fellow can give a white precipitate on addition of barium chloride solution. Barium chloride will give white precipitate of barium sulfate. This pair of compounds which are formed by exchange of the ions make what is called as ionization isomerism. Okay. And then we will be looking at solvent isomerism. If water is the solvent coming out, then that is called hydrate isomerism. If that is something like ammonia, from the coordination sphere this fellow will come out, outside the ion will come in. Water is getting exchanged, that is hydrate isomerism, and if this ammonia is exchanged, then that called solvent isomerism. This type of isomerism can be observed in coordination compounds too. Now, this is the four variants we have seen. Now, we try to answer some of the questions given, indicate the types of isomerism exhibited by the following. What type of isomerism this compound can show? It is MA to B2 type. Actually, it is MAA to B2 type. MAA to B2 type complex can show what type of isomerism? Cis-trans isomerism. And the cis isomer can also show optical isomerism. So, it can show optical isomerism, cis-trans isomerism. Notice that outside there are no ions. This entire thing here, there is a printer's table, there should be a square bracket. Now, notice that this water cannot be exchanged by anybody, because outside there is nothing to get exchanged. Oxalate bidentate ligand, it is not expected to make any other kind of linkage isomerism or any other ionization isomerism, so on. So, this can show only MAA taken twice, X2 type of complex. Don't worry about the counter ion, we will be focusing only whatever that is there in the square bracket. It shows what? Both geometrical isomerism and also optical isomerism. Total number of stereoisomers 3. Now the next fellow, this fellow can show optical isomerism only. Next fellow can show, it's a very complex thing. This is Pentomino Nitrate or N cobalt 3 nitrate if N is linked through cobalt or O can also be linked. Therefore, it itself can exist in a red form and yellow form we have just now seen. The other possibility is when N is linked to it, then the NO3 can come in, NH3 can go out, then that is called solvent isomerism. When this NO3 is coming in and NH3 is going out, two possibilities arise. Whether this is linked through nitrogen, one possibility. When it is linked through oxygen, second possibility. If you count all such possibilities, it will show total 10 isomers. Can you really work out what are those 10? Yeah, there is a challenge to you. Please identify the 10 possible isomers of 3. Your answer should include linkage isomers, solvent isomers and also stereoisomers. Okay, what about the third one? Third one is MABC2 type complex. Can you see that? Now, this type of square planar complex can show cis-trans isomerism. Okay, and you work out the possible isomers it can show, right? Now, give the evidence that this compound they are ionization isomers. I just now said if you add barium chloride it will give white precipitate, if you add silver nitrate it will give white precipitate. Now we try to look at this point of time some important milestones in our discussion. Okay, here it is. First milestone. Please notice everything I want you to carefully observe and these are important. Okay. First point. Ma5B type of complex show no stereoisomerism, but Ma5B can show linkage isomerism if that B is ambident ligand. Notice, whatever that can't show stereoisomerism may show linkage isomerism. That's one point I want you to notice. And another important thing I want you to notice is this. Tetrahedral complexes do not exhibit geometrical isomerism. All positions are equidistant. If all 4 are different, that can show optical isomerism. Okay. I want you to notice this. Square planar complex Ma2B2 can show what? It can show cis-trans isomerism. This is cisplatin, which is a particular medicine to cancer. Okay. Next. If all ligands are different in a square planar complex, 3 possible isomers can exist. Okay. Next. Ma3B3 can exist as Fachner isomers. That is very important. Next, Ma2B2C2 type can exist in 5 possible geometric isomers. The 5th geometrical isomer can be optically active. Next thing. All 6 isomers of this category M, A, B, C, 1, 2, cis. 6 isomers can be optically active. That's another milestone I want you to notice. MAA taken 3 times complexes are optically active. Another point. And MABCDEF type of complex can have total 15 geometrical isomers, and also it can have total stereoisomers 30 because all the 15 are optically active. With this we close this session. Thank you.